Good afternoon, ladies and gentlemen of YouTube. My name is Dan Jones. I'm host of The Dan Jones Show. And for the first time ever on my channel anyway, I'm going to do a quadcopter build video. But this one's a little different. This one is geared specifically for someone who has nothing in FPV. They have no goggles, no radio, no idea what any of this stuff is. This video is geared towards you. So if you are brand new to the hobby, and you've seen other build videos before, this one's going to be a little different and a little bit the same. So hang on in there. I'm going to put timestamps in there for you because it's going to be a long one. But stay tuned. Hopefully this video will give you all of the information in one concise location to get you started doing FPV. So the very first thing I'm going to do is, again, mention that this is for the beginner, the brand new to FPV. I was like you once, about a year ago actually, and I had no idea what an ESC was, from a motor, KV, to all the different other things that came with FPV, including goggles, transmitter, all that stuff. One of the things that ended up kind of getting me into it was the Tinyhawk Ready to Fly bundle, because it came with goggles, it came with a transmitter, and it came with the quadcopter and a radio and everything you needed, a battery and charger, the whole nine. That is a great place to start. So before you even decide you're going to build your own and you haven't tried that thing out yet, try out the new Tinyhawk 2 or the Tinyhawk S, any of the Tinyhawk series, because the Ready to Fly bundles come with literally everything you need. Now, the other option for the 5-inch variants, because the Tinyhawk's a little itty-bitty thing, good for indoors, not so much for anything else, is the Wizard X220. Now, that is the actual first 5-inch thing I ever got. Now, I was told by Joshua Bardwell and other people that that's not a really great place to start, but it's probably responsible for getting a lot of people into FPV, including myself. It comes with a battery, it came with a charger, and it came with a transmitter and the radio and the receiver and everything you pretty much need except for goggles to get going. Well, it breaks really easily, I'm here to tell you. So if you're thinking about going that direction, listen to me and about everybody else and just don't waste your money. It's really not worth it. It was a good experience. I'm not going to say it was a bad experience, but there are better ways to do it. And I think the parts I've listed out here, which will be in the links in the video description, will help you out. I'm going to show you what parts you need to buy. I'm going to show you how to put the parts together. And I'm even going to try to show you how to fly a little bit with all of these different things. The parts I've chosen are picked out very carefully. I spent like a week and a half, 2 weeks, sitting here trying to configure the best set of parts. And hopefully, the goal here is that they're affordable but quality. They're not cheap junk, okay? So you're not going to see DYS or Samguk motors, okay? No cheap garbage here. Quality, but not super expensive. Availability of parts was the other thing. I was looking around, I'm like, well, I could suggest 16 different things on flight controllers, but half the time they're out of stock, the ones that I would suggest. So I'm actually going to be putting together a list of things here that hopefully will be in stock in at least one of the 3 stores I'll recommend. And I'll put links in the video description down below so you can go look and find these parts. Let's start out with the radio. Now, this is the FlySky FS i6 radio. This radio is what got me into FPV. Now, yours, if you buy one of these, will not look like this. I've modified it. I've put an antenna on it, and I've added a LiPo battery instead of using the 4 AA's that it runs off of. But that's how it would ship, is 4 AA's and a little stubby antenna built into the top of the radio. Now, that said, it is an excellent radio for the price. It is not the best radio ever. I'm on to a Jumper T16 Pro. That's what I'm using now as my daily driver. But this is the radio that made me want to do FPV more and more. It's a good radio for the price. You're usually going to see these around $40 to $60 depending on where you buy them from. And they're going to ship with a receiver like this. This is your transmitter. This is your receiver. First thing you're going to need to learn. The receiver receives the commands from the transmitter. The transmitter is going to tell the quadcopter how to fly. Do you want to go faster or slower? Do you want to swing to the left, swing to the right? Do you want to roll? Do you want to flip? What do you want to do? Do you want to turn it on or off? The transmitter does all of that. Next is the flight controller. The flight controller is like the motherboard of the quadcopter. It's the brains of the operation. There are several different brands and styles of flight controllers, but hundreds really. But the one I'm going to recommend you go with is the CL Racing F4S. That is the version 1.6. This should cost you no more than $35. It is a very well-rounded budget option, but quality nonetheless. It gives you lots of options and features for when you get better at flying. For example, this feature called Black Box, which is something that'll monitor all kinds of stuff coming off your quadcopter and tell you what's going on with it once you learn how to read that. This has Black Box SD card, which is really nice. It also has the option to plug in a 4-in-1 ESC, something we'll learn about later, but it's a nice future option that you can add to this down the road. It's very easy to solder. It's very easy to install stuff onto, as the pads are very large. I also recommended this not just because of the price, but because it's pretty widely available for around $30 to $35. However, I'm not going to say it's always going to be in stock. So as a backup option, and honestly the part I was going to pick as well, was the Joshua Bardwell F4 all-in-one flight controller. Now this flight controller is out of stock at a lot of different places half the time. So I couldn't recommend it because it's out of stock so frequently. But either one of these is a good choice. The CL Racing F4 or the Joshua Bardwell F4 all-in-one. All these are going to be linked in the video description down below. The next part is the frame. The frame is like the chassis. It is the case. If you were building a computer, this is what holds the quadcopter together. This has to be made of quality. It has to be put together easily. It has to be affordable. All these things I'm thinking about when I'm putting this build together. I thought it has to be the Source One by TBS. There's no other options I could think of. The second option to this, though, if there is one other option, is the CL1 by Rotor-Riot. That is a great frame as well. The only reason I didn't suggest it is because it's out of stock so many different places. They cost about the same. This cost about $27 and the CL1's about $35. So there's a $10 difference. But for $10 more, you do get thicker arms and a heavier frame. So it's a little bit more durable. But I absolutely love the Source One. It is one of the easiest frames to put together and build a quadcopter in. It is incredibly reliable and durable. It is so much fun to fly, and it is less than $30. And it's in stock pretty much everywhere. So again, I'm going to link for both down in the video description, but the Source One frame is the one I absolutely recommend you start out with. Top of the line here for the money, $27. Buy 2 of them, and if something breaks, you'll have spare parts. I mean, for the same amount of money as you'll spend on a nicer frame that doesn't come with spare parts. So next is the motors. The motors are what make the quadcopter fly. You attach the motors to the arms, the motors spin, and they spin the props, and the props make the air move, and it flies. You probably know that by now. Motors are a very important decision, and this is the reason I've chosen the Emax Eco series. This is the Eco 2306 2400 kV. That's a lot of numbers I just threw at you, but don't worry. We're not going to dive into the technical details of all that. All you need to know is that the 2400 kV is basically telling you how fast these motors are going to spin. The reason I chose 2400 kV is because we are going to be building a 3S/4S battery build, meaning that the battery we're going to be using is either going to be a 3-cell battery or a 4-cell battery. Batteries are a whole other video, but we'll quickly hit on those in just a minute. 2400 kV is kind of in the middle. You can go a much higher kV, 2700 kV, and these motors will spin much faster, meaning that your quadcopter will go much faster. However, they will also burn up your batteries much quicker. 23 and 2200 kV are slower, and they'll burn up your batteries a little slower. However, I feel that 2400 is a really good middle zone. It's not too fast, it's not too slow, and it's not too rough on your batteries, depending on the quality of the motors you buy. Ecos by Emax are absolutely 100% quality motors. They usually run about $12 a pop. Now, there are motors like Raystar and DYS motors, which can be as cheap as $10 a motor. However, they will not last. They are not made very well. They just sometimes fail for no apparent reason. Spend the extra $2 a motor. Trust me on this one. the Emax Ecos are the way to go. Okay, the very next thing you're going to need to purchase are ESCs. ESCs are electronic speed controllers, and these are the things that take the voltage from your battery and then take a signal from your flight controller and tell the motors how to spin and how fast to spin, what direction to spin, when to spin, all that stuff. They are essentially like the pre-motor, the transmission almost, if you will. So the Xylo ESC is the way to go, in my opinion. They're going to be easy to attach to your flight controller. They're going to be easy to install onto the quadcopter. They're very easy to mount the motors to, as far as soldering the wires of the motors to it. They work incredibly well. They don't just burn up and fry like some cheaper ESCs, and that's going to be really important because, let me tell you, if this thing goes in the middle of a flight, your whole quadcopter is going to spin of death, roll, whatever, and crash somewhere that you don't want it to crash, and probably break other components with it. When an ESC fries, it can take out a lot of other things with it, so it's very important that you start with a quality ESC. For the price, I don't know a better ESC than the Xylo 40 amp ESC. So please trust me on that one. The next thing you're going to absolutely want to pick up is a video transmitter. A video transmitter does exactly what it sounds like. It transmits the video. And the one I'm recommending is the Rush Tank. And it's pretty much the best video transmitter on the market. It's a little bit more expensive than a lot of other options. I could have said, get a $10, Panda, there's all these different VTXs out there that are cheaper. This one's about $35 to $40. That's a lot of money. But when it comes to flying FPV, video reliability is absolutely critical, as you're getting a video feed from your quadcopter into your eyes. And if you can't see where you're going, you're going to crash. So it's really important that you get a reliable, quality VTX, and I could not recommend one more than the Rush Tank. The Rush Tank, as you can see here, has these mounting holes that make it incredibly easy to install. You just literally stack it up with your flight controller and other components, and in the TBS Source 1 frame, it's going to be incredibly easy to install. It has what's called an MMCX connector. There are UFL and MMCX type connectors. MMCX kind of locks into place and doesn't just fall off, where UFL connectors tend to kind of just pop off depending on how you install the VTX. So it was a no-brainer to me to recommend this VTX. Your VTX is only as good as its antenna, though, and if you don't put a very good antenna on the end of the cable that it comes with, you're not going to have a good time. So there are 2 or 3 actually antennas that I'm going to recommend you buy and kind of play with them. They're not that expensive. The reason I'm recommending you buy 3 of them is because they're 3 different styles. This one has a coax cable attached to it. It's a Xylo Axi. Okay, and RHCP is what you're going to want to look for every time you're looking at any sort of antenna, and I'll explain why later. But RHCP just means right-handed circular protocol. It's the style of frequency waves that come off the antenna, okay? They all have to match. Your antennas on your goggles and your video transmitter all have to be RHCP, and when we talk about what goggles I'm going to recommend you get, this is why I'm going to say just go ahead and buy everything RHCP. All right, so we've talked about the video transmitter, we talked about the antennas, but we haven't actually talked about the video that you're going to be getting, and the video comes from a camera. You're going to need to get a camera, and the camera I'm absolutely recommending without even a shred of doubt is the Foxeer Predator Mini. It's a little more expensive than my second choice, which I'll mention, but the Foxeer Predator Mini, the reason I'm suggesting this over pretty much anything else is the way it's built, and the video quality is just superb. The reason I recommend the Foxeer Mini Predator is because it fits the TBS Source 1 frame incredibly well. It's very, very durable. When you look at it, it is completely enclosed. There are no electronics exposed at all, and I think that is absolutely incredibly important when it comes to us, not just a beginner, but anybody flying FPV. You need to have that layer of protection if you go to crash. That stuff can't just get right into the electronics. Some cameras, a lot of cameras actually, have the electronics open to save weight. We don't really need to worry about that right now, and honestly, with as much as this thing weighs, it's not that big of a difference. The lens is also replaceable if or when you decide to crash into a tree head on and you crack the lens is very easily replaceable and they're very widely available. The next thing we got to talk about, of course, after the camera, the video transmitter, and all these antennas is, of course, how you're going to see where you're going, and that's going to be inside the goggles. Now, if you went ahead and picked up the Tinyhawk Ready to Fly bundle, you probably already have the transporter goggles that come with that bundle. If you didn't, then this is an excellent goggle to start out with. For $40 to $50, depending on where you go to buy it, the transporter goggle is a diversity receiver, meaning that it has two antennas and it picks up the signal from two different places, making it a much more reliable video signal in your eyes. It's very easy to use. It's a very reliable goggle, and the video image is actually really good for the price. Box goggles mean that you basically put these on your face and it's a singular screen inside of a box. It's just that simple. Some people want to record what they see in the goggles, and that requires a DVR. A DVR is digital video recorder for, those of you who have been on the moon for the last 20 years, but basically it takes your video signal from your quadcopter into your goggles and records it to an SD card on your goggles. These tend to go up in price, but there is one brand that's pretty reasonably priced that is decent quality, and that is the Eachine EV800D, and these were my daily driver of goggle for the better half of the last year. I like these goggles. I don't love them. Now, I'm not going to get into the reasons why they're great and why they're not great, but they do have a DVR, meaning that you can record. They have diversity, so that means, again, you have that two sources of signal getting in, and they're pretty easy to use as far as like the menus and functionality and stuff. So, there's that. The video quality is pretty good. It's not the best. It's not the worst. I'd honestly go ahead and say that the transporter from Emax has a better screen in it. That's just my 2 cents. I think it just looks better, looks clearer. But these are built a little bit bigger, so you tend to get less what they call light leak, which means that you're just seeing the screen and not like the sun and stuff peeking in like you will on the Emax goggles. The head strap that comes with the Eachine goggles is not very good, so just kind of keep that in mind. The battery life on these is not very good as well, whereas the Emax goggles will probably give you at least 2 hours easily solid. These will maybe give you 45 minutes before you're going to have to charge them up. Now, that's not that big of a deal for some people, but just some things to mention. All right, next on our list is the battery. You need to power all this stuff, right? So what kind of battery should you be getting? I started out flying what was called a 3S pack. 3S packs provide a little bit less voltage, a little bit less power, but are a lot easier to learn on. And honestly, if you're not dedicated to this hobby quite yet and you're not sure if this is going to be for you and you're not going 100% all in, start with 3S. Here's why. A 3S battery is going to cost about the same as a 4S battery, but the charger that you need to get for a 3S is going to be significantly cheaper. These are Z Power, ZEEE 3s, and these are 1500 milliamp 3S packs. I've actually used these quite a bit, and I can safely recommend them for the price. They're pretty much only available on Amazon, which I don't like recommending, but they are pretty much only available on Amazon, and the prices are not terrible for what you get. The quality of the battery is not terrible. There are cheap batteries that will puff or swell or fall apart or explode or who knows what else very quickly and break down and not last very long. And then there are very expensive batteries that won't do that, but are sometimes out of your price range. Z kind of falls into the middle. If you think, hey, I'm going into this thing all in, I want to have the best experience possible, for 4S batteries, look no further than the Tattoo. Anything by this company, Tattoo. The particular battery I have here is the R-Line 3.0, or 2.0, I'm sorry, version 2.0. Now, these I got on race day quads for like $15 a pop, which is actually into the dangerous cheap battery territory, but this brand is not dangerous cheap battery. There's this company called Zop, Z-O-P. Don't buy anything they make, okay? All right, so Tattoo, anything, even if you get the 3S variants of theirs, you're safe. Z is what I recommended because I know the prices and I know the availability. But Tattoo, if you even go with the 3S versions of these in Tattoo, you're going to be just fine. Tattoo makes a quality pack. Ask anybody in the industry. They're going to cost a little bit more, But trust me, your money will be well spent when it comes to safety, reliability, and the longevity of the battery, assuming you don't crash and destroy the battery really badly. Okay, so we talked about batteries. Now we have to talk about chargers. I don't care if you're going to be in this hobby for a week or a year or 3 years, you need to buy a LiPo safety bag. They do not cost that much. Amazon, Get FPV, Race Day Quads, everybody sells them. They range between $5 and $20 depending on the size and the quality of the bag. I will link in the video description below several different options, but a decent LiPo bag is absolutely required. 3S or 4S, depending on which way you want to go. How dedicated do you want to be? If you're going to be going, I'm dipping my toe, I don't want to spend a whole lot of money, I don't have to. I just want to see, I might buy 2 3S batteries and a charger. This charger is the IMAX RC B3 Pro. It's a very, very basic charger. There's really nothing spectacular about this. But it's usually like $10 to $15. And I'll find you this and variants like it and link those in the video description. The reason I recommend this is because it is a balance charger only, meaning that when you plug your battery into it and you plug it into AC power, it balance charges your batteries, which is the only way you should be charging any battery. It's straightforward. Red means it's charging, green means it's done charging. Is it the fastest charger in the world? Absolutely not. It will take you a good 45 minutes to an hour to charge one battery, which is a long time. Is it the best for the money? I think so, or the variants like these, and I'll, again, suggest a few of those. If you're like, I'm going in, I want to have good quality stuff, and I think this is a hobby I'm going to be in for a long time, then obviously go with the 4S packs. Okay, they're about the same amount of money for the most part. And the charger I absolutely recommend, and honestly don't look any further than this, is the ISDT D2 Smart Charger. It's expensive, usually $130 to $150. It's very expensive if you're just starting out, but it is intelligent in the sense that it will stop you, for the most part, from blowing up your house, where this one will not. This one, you just plug and go and hope for the best. We'll talk about battery charging more in detail here. Just bear with me. The ISDT has a lot of different readout information. It plugs into any wall socket in your house. And it's just really simple to use. You can also charge 2 batteries at a time, which is kind of nice. So you can get 2 packs done, and usually it takes about 30 to 40 minutes for 2 packs, which is really nice. If you decide to stay with the hobby, it supports something called parallel charging. We're not going to talk about that right now, but basically it means you'll be able to charge multiple packs at a time. That's something you're going to need to educate yourself on before you start doing it. I told you this was going to be a long video, and that's why I'm time-stamping everything. I wanted to go over each individual part. And there are some parts I left out that I'll mention as we start to put this thing together, but don't worry, links to everything will be in the video description. So let's go ahead and start building this thing. The first thing we're going to need to do is assemble the frame. Now, again, TBS Source 1, it's a great frame, and it's incredibly easy to assemble. I'm going to give you the basics on how to put this thing together, and I trust that you're quite competent and will be able to figure it out without me literally holding your hand through the whole process, but I'll do what I can for you. Alright, so we get everything out of the bag. I've actually got some nylon standoffs off to the side here. I recommend you buy yourself a set of these. These were from Micro Center for $15, but they work pretty well. I'll put some links in the video description to Amazon and RDQ and all the other style ones that you can get, but pretty much you're going to need a set of these, as well as M3 screws. And again, I'll link these in the video description. You're going to need some hardware. You want to make sure that when you go to put this plate on, that it lines up. You have 2 in the slot, and then that you make sure you're putting the screws in towards the thread, so this side is where all your stuff's going to go, like your actual flight controller. This is going to be the top, this is going to be the bottom, and then this can go any direction. Same thing with these, as long as they just line up, matching the holes. So let's get one of those in. Start with one screw, 1 arm, hex driver 2.0, and get it started. Doesn't have to be crazy good. Just make sure it's not super tight so you can still move it around. Just like that. It's not tight yet. And then I take another arm diagonally, and this will make it much easier to install the last 2 arms. So here we go, like so. It's pretty straightforward. The screws that you just installed should be flush with the frame. And we've got 2 in, so we'll get the other 2 arms. Okay, give all of them a good once over. So if you wanted to do 20 by 20 equipment, you put those screws in the middle here. If you want to do 30 by 30, you put them on the slightly outer edges. And now you got these 2 nubbins sticking up, and that's where we can install our first nylon standoffs. I use slightly taller ones to get started. And just do it finger tight. And that's it. So now we're going to install these spacers, and these are pretty straightforward as well. We just have these screws, and these you may want to stick some Loctite on, but in all honesty, I don't. It's nothing against Loctite. I have it. It's sitting right there. I just know myself well enough to know that I'll take this apart again a few more times before the end of its life. And Loctite just makes that more difficult. Okay, now the spacers are in, 2, 4, 6, 8. This will make it slightly more difficult to build in, as you're going to have to work around that, but at the same time, it's also going to be easier in the sense of you're not going to have to redo anything when you go to attach these. You're already going to be ready to rock and roll because, well, you'll know where you can and can't put wires because these spacers are going to go. They're also going to kind of help you route things as well. Okay, so we got the frame assembled. The next thing we need to do is get the flight controller ready. So we got the flight controller out of the box, and we actually are going to have to do what's called tinning some pads. Now, at this point, I'm going to tell you, if you don't know how to solder, you're going to want to stop and go learn how to solder because, well, that's kind of a requirement for this hobby. And the iron I recommend is the IUA 469. It's like $30. Great soldering iron station. Absolutely love it. And the solder I'm going to be using is actually from Race Day Quads. It's 6337 rosin core solder. So it's the 0.8 millimeter. It's pretty thick. And we're going to be fluxing with rosin soldering flux, the CAIG brand, CAG or whatever. First thing we're going to actually attach is the XT60 lead to get power to it. There are 2 kinds of XT60 leads I'm going to link down in the video description. The first is the one that has a built-in capacitor. The built-in capacitor one's the one I'm going to be using today. And then, of course, there's just a plain Jane XT60. So what I'm actually going to do is I'm going to put a little bit of flux on the ends of these leads, and then a teeny tiny little bit of flux on the battery plus and battery negative pad on the bottom of the flight controller. And that is right there. So got the flux going. The other thing I have set aside is the leads from the camera. I'm going to have to tin those. The leads from the video transmitter, more on that in a second, and the lead from the receiver. Okay, I'm going to tin those later. All right, I have my helping hands. These are a $5 investment with a magnifying glass, and they're well worth their weight in gold as well. All right, so the ironing tip I'm going to be using is this medium size, like a chisel style tip. It's not conical, and I definitely recommend you do the same. Conical tips are just too small for this sort of thing. All right, so we give ourselves some solder, and we're going to re-tin these tips. Now we have to tin the actual flight controller pads. Wet the tip. Solder goes where the heat is. So if the solder's not leaving your tip, there's not enough heat on the pad. Now I like to preheat the negative pad and then feed solder into it. That's it. You don't need a lot. So pretty much what you should be done when you're done, it should be a shiny little ball sitting on those two pads, negative, positive. At this point, I'm going to take the clamps that I have. I'm going to grab the negative first because negative is going to be the hardest one to do. It takes the most heat. And I'm going to clamp that down, and I'm going to hold it pretty much straight across like this. Another useful bit of material you're going to want to maybe invest in is some Loctite Fun Tack or whatever. And that's going to make it really easy to hold things down when you're soldering them. That's that blue stuff there. All right, here we go. We're going to solder up the wire and just kind of gently apply pressure and wait. Don't do anything. Okay, I'm going to take the Fun Tack off. What I like to do is release my clamp and give it a little squeeze, little tug. Okay, shiny is good. Shiny is what you want to see. That's it. Same thing, give it a tug, kind of move it around, ensure positive, red, negative, black. Okay, so there's flux on there, and you're going to want to clean that off. It doesn't take much to get it off, but pretty much I like to use a dry brush and just sort of brush off the excess flux. Now what we got to do is we got to tin these pads for all these other accessories, the camera, the video transmitter, and the receiver. And that's it. All right, now that we have the XT60 all ready to go, we actually now need to tin the rest of the pads. So there's an online diagram you can look up for this when you go to do it yourself, but pretty much, I'm going to go ahead and show you on camera here as best as I can. You're going to need to tin all the necessary pads. And you're not going to need to tin every single pad, just the ones you need. The ESC, positive, negative, all four of those, 2, 4, 6, 8 rather. So 1, 2, 3, 4, 5, 6, 7, 8 for all four motors. And then the motor 1, 2, 3, 4 pads, that's the signal pad that's going to tell the motors when to spin. Then you're going to need to actually get the rest of these leads ready to solder on. For the receiver, you're going to need to tin the 5-volt and ground pad down here, and then RX4, because we're going to be using a free or a fly sky receiver, not a free sky. If we were using free sky, we'd actually be up here under where it says S-Buzz. But that's not what we're going to be doing. So we're going to be taking RX4, which is receiver number 4, and that's where one of these wires, the yellow wire, is going to go to, and then red and black to 5-volt and ground to power the receiver. Then we have the video transmitter. You've got VTX positive, VTX negative, and then VTX signal. Okay, so pretty much what we're going to need to do is take that video wire and we're going to put that on VTX S, and then positive negative is going to be that red and black, and actually we're going to put both blacks on that for a better ground for VTX negative. And then we're going to actually go over to the other side of the board, and there's this TX6 pad down here. We're going to actually use that for that light blue wire. We call that smart audio, and we're going to hook that light blue wire up to that for TX6. Then we've got our lost quad alarm. Now, when it comes to lost quad alarms, there's one brand I recommend, and that is ViFly, the ViFly Finder 2. Never lose your drone again, which is true. This thing is quite effective. It's got its own little battery source. It's got these little cables, and pretty much what it does is it detects when your quadcopter's lost power in a crash, and you're going to absolutely want to have one of these installed because you will crash, and you don't want to lose your quad. This thing will beep like crazy when it's hit the ground, and the battery is ejected. You're going to be able to find it really easily. Okay, so we've tinned every pad we need for this operation to be successful. Next thing we're going to do is actually we're going to tin all the little wires. So we've got the receiver, the video transmitter, the camera, and the buzzer wire. Next thing to do is just go ahead and install all these to the flight controller. I'm going to grab my clamps here, and first thing I'm going to do is put my signal wire from the receiver to the flight controller. And remember, we're using RX4. So I got to find RX4 there. Camera signal, video in, power, positive, power, negative, and then that's V-sense. We're actually going to go ahead and just going to snip that and wrap it around and call it a day for that wire. That's it. Video, power, that's all we need. And this is for our receiver, this is for our video transmitter, that's for our camera. Got all the wires attached to the flight controller. Video transmitter, camera, buzzer and lost quad alarm, and of course the receiver wire. What we need to do now is actually bind the receiver to the transmitter, and this process is going to make it so your radio will talk to this quadcopter. The reason we do this before really doing anything else is because it's going to be a lot easier to do it with everything taken apart. So if you ended up getting a FlySky transmitter and receiver, you'll probably have this receiver that came with it, okay? This is the FSIA6B. This is the binding wire. It's a little loop of wire. Pretty much if you're looking at it head on, you got all these pins. It's the 3 all the way to the far right looking straight at it on the very bottom. You're just going to cross those like that, okay? So that's where you put the binding wire. Now, our wire that's going to actually attach to the receiver is red, black, and yellow, and that is our power and our signal. Okay? Now, again, if you're looking straight at it, you're going to have 3 wires going horizontally, 3 pins rather, on each side, 3 and 3, and then a bunch going vertically. You want on the right side these 3. This is what's called I-bus. Basically what we're going to do is we're going to make sure that our yellow wire is our signal wire is all the way to the far right. Red is in the middle and black is to the left, and that's going to just slide right in. Now, something I want to mention while we're talking about this receiver, you may be going, I don't have this wire. If yours didn't come with that wire, you're going to need to buy a little pack of jumpers from Amazon. I'll link in the video description. These are female to male, and these are like for breadboarding. And you'll get a big pack of these. You won't just get 3, but I picked out these 3 and I stripped these off from the pack: red, black, and yellow. And these are a way for you to attach this to your flight controller. And basically you're going to do the exact same thing we did, except with slightly bigger wires. Instead of doing this and tinning red, black, yellow to the flight controller with this harness, you're actually going to do these one at a time. You're going to snip these to length, tin the ends, and then red to red, positive 5 voltage, yellow to the RX4, and then black to the ground, and then you're going to actually hook it up just like that. It's going to be pushed into these pins and then the signal wire, and it's going to be just like that and soldered onto the flight controller. So if you don't have this wire harness, that's what you're going to have to do. All right, so remember, black, red, yellow, black, red, yellow. We're going to slide that in. This is also a good opportunity for us to do what's called a smoke check. And what that means is we're actually going to plug in just the flight controller and nothing else, but we're going to make sure nothing explodes. And the way we're going to do that is with what's called a smoke stopper. And that's this device right here. I'll put a link in the video description for that. This device actually will help prevent you from frying your electronics if you plug in a quadcopter that has something shorted out. And that's bad. So I've got this rigged up to my own homemade power device that I'll put a card in that basically how to make one of these and then how to attach this to it. It's really easy. This is a great way to test your stuff out. So what we're going to do is we're going to actually plug that into the XT60 here in a second, and then we're going to bind our receiver to our transmitter. So I got to get the transmitter. And the first thing you're going to do is set up the transmitter. You're going to turn it on, make sure the batteries are in there, okay? And what you're going to do is you're going to go and hold down the OK button. Okay, you're going to System and Setup. You're going to go to System, press OK. Model, select, hit OK. And basically, you're going to be stuck with Model 1, Fly Sky 1. Okay, it's pretty self-explanatory. Hold down Cancel to save that. Go down. You can rename it if you want to. And there's nothing wrong with that. Just take some time. Model type select. Make sure it's set to airplane or glider. Okay. There's other options. You don't want those. You want airplane or glider. Okay. Then you're going to go down to RX setup. Hit the down here. Go to RX setup. Hit OK. Then you're going to go to AF HDS and make sure it's on. That's how it's going to actually talk to the receiver. Make sure that's turned on. Not off. PPM output. You're going to make sure that that is off. We don't want PPM output. We want that off. All right, RX battery, we really don't need to mess with that if you're using AA's. Fail safe, go to fail safe, hit OK. Go down to channel 3. Yours is going to say all off when you first get to it, but you're going to go to channel 3 and you're going to hit OK. And this is your throttle channel, okay? So throttle all the way up, throttle all the way down. We want to make sure it's all the way down. And then you're going to press and hold cancel. Right, so we're at -100 for channel 3. Press and hold cancel. That saves that. And now if this thing stops talking to your quad, it just drops it out of the sky, which is the safest thing you can do. Go back and then go to function setup. Hit OK. And what you're going to do here is your aux channels. You need to set up your aux channels. So aux channels are these buttons and switches up here. So you've got 1, 2, 3, 4 switches and then 2 dials. We don't want to use the dials. We want to use these 2 switches right here. And above it, it says SWC, SWD, C, and D. Okay, so this one we're going to make our arm disarm, and this one we're going to make our mode switch. Okay, we're not going to use these. So what we're going to do is on channel 1, or it says channel 5 rather, you're going to up until it says C. That's this switch here. And then you're going to hit OK. And then you're going to channel up on channel 6 until it says D. So switch C and D are now channels 5 and 6. Press and hold cancel. And that makes these 2 switches activated in your receiver and transmitter. And that's pretty much it for right now. Okay, so we're going to turn this back off. All right. So the first thing I'm going to do is I'm going to actually leave that bind wire plugged into the receiver and make sure there's nothing metallic or conductive sitting underneath of it, and we're going to plug in the smoke stopper. And that's it. So now it's in bind mode. This LED should be blinking. So now what I'm going to do is I'm going to hold this bind button and power up. That's it. You're done. And now you'll actually have information here coming back from this receiver. It's saying that you have TXV1 INT or instrument voltage, which is 5 volt. That's this. And then error percentage is basically how weak or strong your signal is. The lower that number, the better. Okay, that's it. You're going to take the bind wire out. Okay. You're going to unplug it. And then you're going to watch that information disappear. Yeah, pretty straightforward. And you're going to plug it back in. And that's what you want, is this thing to talk to that thing automatically. Now it's ready to go. Okay, now that your receiver is all bound and ready to rock and roll, we can set that aside with everything else. And we need to set up the frame with the components inside. So I've already taken the liberty of installing the VTX. This is pretty straightforward. The VTX is going to go in with the antenna off to the left and the little wire harness patch right here off to the left as well. Kind of route it around and through the spacer. We're going to take care of this in a second, and I'm going to choose to use the longer of the two style antennas, and I'll show you why in a minute. Alright, so the pigtail for the antenna wire is around. I've got the standoffs already installed for the flight controller, and I prefer setting it up like this because, one, we're going to have airflow underneath and in between the flight controller and the bottom of the frame for the VTX, and it's going to make it a lot easier to route all our wires to the flight controller with it being on top. Okay, so I've already put the standoffs on, and the way to remember which way is the front of the frame, which way is the rear of the frame is actually with the camera mounts. So what you can do is you can actually just kind of wedge those in there, or just one of them, and that'll be a constant reminder of where the front of the quad is. Okay, you just always want to make sure these are both oriented the same direction when you put the camera on. So that's the front, this is the back. So when we install this, we're going to make sure we do the same thing. This is the front going, this is the camera, this is for our video transmitter. It's going to go right around the corner and underneath there. This is for our receiver, which is going to be right on top here, and then this is going to be our lost quad alarm, which is going to go right behind the camera. Okay, so we're going to just kind of slide that on there real quick, and that's it. That's pretty much everything you're going to have in there. You want to make sure you have plenty of clearances for your wires and everything, and it looks like we're okay. We're not going to ground out on anything. And pretty much from here, what we're going to do is we're going to get ready to run our ESCs. And the ESCs are going to be attached to each arm. Positive and negative and signal wire are going to go to the flight controller. The frame is actually conductive, and sometimes if the ground of your antenna pigtail touches the frame, sometimes it can cause some video noise and disturbance. So you want to make sure that this antenna is on there pretty tight so it doesn't just come loose. And then I like to just take some thin electrical vinyl tape and wrap it around the end of the pigtail. And this is just to make it electrically insulated. And then what I'm going to do is I'm going to grab a zip tie. Alright, so we've got that. We're going to zip tie it. That. So now the antenna is mounted to the frame for the VTX, and we are good to go there. The receiver is going to actually get installed upside down like this. It's a bigger receiver, and there are smaller ones available. You may want to consider buying one instead of using the one it came with, but just in case you don't, I'm going to show you that this can work with the one it ships with. So again, we're going to make sure yellow is all the way over. Plug that in. It's going to be really difficult to do otherwise. Give it a good couple of twists to make sure that she is nice and wrapped up. And this is going to kind of just wedge right in between the spacers. And I like to put the XT60 laying over top of it, so it's easier to move around the XT60. And that's it. So basically now you can actually drive down, once we're all done later, drive down the flight controller, and your antennas for the receiver are going to be out the back along with your video transmitter, and that's kind of what you want. You want all the antennas to be in the same place, and we can mount these up later once we're done building it. It's one of the last things we'll do. Now what I like to do is I'm going to start attaching the ESCs to the arms. What I like to do is I like to take these spongy cushions, or whatever you want to call them, for the arms. Alright, so now we're going to have to take some tape. I like using the white vinyl electrical tape. And we're just going to go around that one full turn. That's it. Let me do that to each leg. Okay. Alright, so now we've got a space for our ESCs to get mounted. And this is going to be electrically insulated, so the bottom half of the ESCs doesn't rub on the frame and possibly short out. It also keeps those landing pads attached to the frame so they never just flick off, which is really easy to do. So now what we're going to do is we're going to start zip tying all the ESCs to the motor, to the arms. Pretty much what you're looking to do is the ESCs are pretty long. So you want to mount them like this, label side up. It's a little flatter. You have the capacitor sticking up, so this will kind of be a nice flush flat mount. Pretty much what I like to aim for is making sure that the 3 spots for the wire is right in the middle of where you put the electrical tape, and pretty much you're going to have the wires kind of shoving in between the standoff and the spacer, and then we'll deal with these later. So right here is where I'm going to zip tie that down to, and I just kind of hold it, and you can zip tie it and tape it, or just zip tie it or just tape it. As long as it doesn't move, it really doesn't matter. That's pretty much it right there. So we've got all 4 ESCs zip tied down nice and snug right in the center of the insulating electrical tape. This is going to set us up real nice to mount the motors, snip the wires, and solder them directly to the ESCs, and then we'll be able to solder up the ESC cables to the flight controller. So next step is to install the motors. What you're going to want to do is grab one of the motors, and pretty much all we're going to do before we do anything with the wires are the motors themselves. So we're just going to make sure that when we screw these in with the screws they included, that they're not too short and they're not too long. It's probably just equally important on both of those. So what I'll do is I'll take this screw here and I'll just slide it on in, and I'll hold up the motor mount right next to it and kind of just see, is it flush? And it looks like it probably will be. So we'll put one of those in and go from there. So again, we're going to use H20 just lightly. We don't want to go too tight. This allows us to keep moving it around and line up the other holes. And we're going to do the same thing across the board. Now, it doesn't matter which bag you grab, just as long as you end up with 16 screws. 4 times 4. So the screws that come with the Ecos are good enough, but some people may say that you may not want to go with these smooth screws, as they do strip a little easier. So you may want to find identical lengths of a better quality screw. And again, I'll put a link in the description for this kit. So once you got the motor mounted, just kind of make sure, alright, give them a good once over diagonal pattern. Just make sure they're tight. And then again, make sure none of the screws are sticking up, touching any of the metal windings. You're going to do this 3 more times. Okay, so we've got the motors all mounted up. And another thing I want to mention real quick is that if the screws that come with it aren't long enough, or they're, not quite the right length, that's what the kits are for. There's 2 kinds of screw heads. There's these smooth, and then there's these boxier style. I'll kind of hold those up to the camera here. These tend to be a heck of a lot more durable, so keep that in mind if you are going for longevity. Maybe switch them out, but these will work just fine to get you going. If they're not long enough, again, though, find the right length. Just make sure that they aren't protruding past the motor mount to where they could be touching the windings, causing ground outs, and that's a lot of problems. Make sure that they're in there nice and tight. You can put Loctite on the threads, but again, that makes them harder to take off later, and the main thing to do is just go over all the screws every so often, every so many flights, maybe every flight, and just make sure they're all tightened down. Alright, so now we are almost there. So we're going to take this and set it aside, and the next thing we're going to do is we're actually going to solder the motors to the ESC. And this is going to be kind of tricky because we're going to have to cut the wires to length, right? But it looks like the ESCs being so large, it's going to be very, very difficult. So we're going to make sure all the ESCs are pushed up out of the way as much as possible. and giving us as much clearance between the motor wires and the ESC as possible. So again, you're going to have to kind of shove them wires in between the spacer and the standoff, because these are very large ESCs, but this frame and these arms do accommodate ESCs quite well, even these larger ones. Once you've got them pretty much pushed up as far up as they'll go without breaking anything, then you're going to get your snips out and you're going to cut your wires to length. What I like to do is bring them together and go past the 3 contacts here. All right. Maybe like cut them right here, because you're going to have to strip off some of that jacket, and sometimes you make mistakes. It's always better to be a little too long than it is a little too short. Am I right, ladies? Strip off just a teeny bit of the braided wire inside. Now remember, if you do end up going a little too short, it's not the end of the world if you need to lengthen the wire again or something. It is, just soldering 2 wires together. For these lengths, though, not ideal. So now we're going to tin the pads and the wire, and then we're going to put the 2 together. Wet the tip and tin the pad. That was me being stupid. Yeah, see, I'm in a rush. Don't rush. Take your time. Enjoy it. Take 1 to 1. Let it sit and sink in. You're going to need to kind of bend the wire in a little bit to flatten it out. Shiny is good. If it's not shiny, if it's dull, or if it's just doesn't look clean, do it again. These are the most important things you need to solder. This is how it gets in the air. If these break or if these have cold joints, you're going to have a problem. There you go, 1, 2, and then last but not least, number 3. And now what you do is you take your electric tape and you go around it 1 more time. You could add something called silicone conformal coating, which we're not going to be doing today, but for another $15 or so, you can order a bottle of this from Amazon, and then basically when you're all done, you can coat all the electronics with that brush in there, like a nail polish, and it'll help water resistance your electronics. So that's that. That's taped. That's zip tied. We can always add a zip tie or replace it if necessary. Zip ties are a dime a dozen. You'll need a lot of them for this hobby, as well as tape. And that's one of the motors ready to rock. We're going to do the same thing 3 more times. Okay, so you've got your ESCs all soldered to the motors. Okay, put some tape around it to keep it insulated. We now have to fire up the power to the ESC and then the signal wire. Okay, and we're all zoomed in. All right, this is your signal wire and ground. It's got this neat little end on it, which we're not going to be able to use. So we're going to snip that off. Right there's fine. I like to keep these for other projects. And the signal wire and ground I actually keep a little longer than everything else. But the power, red and black, I'm going to snip these down to size. Now if you look here, we've got ESC positive, M3, ESC negative. Really like this flight controller for this layout because it's going to make it really easy to go red, white, black, black. So we've got 2 blacks, these 2 right here, and then a white, which is our signal, and then our red. What we got to do first is we got to cut the red wire down to size and then tin it. Probably going to land about right there. I don't want it to be super tight, so I'm going to cut just a hair over that. So I got some room to rip off some of the jacket. Again, silicone jacketed wire is really, really easy to strip with your thumbnail. Okay, you won't need much more than that. So there's your red, all nice and tinned. Another thing to remember is that the standoff right there is plastic. Okay, you don't want to melt the standoff, so just be mindful of that when you go to set these down together. They're together and they're flowed. Shiny is good. Shiny is great. Okay, that's it. So now we do the same thing to the signal wire. Strip it off. I don't care. I like leaving these extra long. Just a personal preference thing. There's no real reason for it. Just easier. And they're really thin so that you can tuck these away pretty easily. What I'm going to do is I'm actually going to trim this because I don't want this bridging anywhere. Let's do that. Here we go. And that's it. Okay, give it a tug, make sure we're good. Yep, and yep. All right, now we got to do the negative. Same dealio. We want to kind of cross over. And we'll do it about right there. Yeah. Strip off a little bit, not much, just enough. And we'll do the same thing here. Strip it off. Give it a look. Make sure. Not the best, but not the worst. And we're going to add this little itty bitty black wire to the big black wire. Ground them together. Lot less chance of issues. Alright, so signal, power, and ground. That's going to basically control this motor here. Okay, so now you've got positive to ESC positive motor wire, the white wire to M, 1, 2, 3, and 4 across the board. Black wires to ESC negative, and then of course the thin black wire to the same pad. And then you're going to want to go ahead and button the standoffs down as you kind of move your way around as to not melt them off. So like these two over here are in, but we were just doing these, so now I'm going to go ahead and just put the last in. I like these taller ones as you can grip it with your thumb. You can use these teeny tiny little, they're just, not as easy. So you can actually do this by hand. These do not have to be on like super duper also, super tight. You just have to make them snug. They're plastic. They will break. You will have to replace them after crashes. Just bear that in mind. Okay. So now we have the ESCs and the motors installed. We've got the receiver installed. Now all we got to do is plug in the video transmitter and hook up the camera. Okay. That's just to keep it organized. Slide that in to its home. Are you too good for your home? So we're going to attach the VTX wires all twisted up. Keep them organized. They're in. We're going to take our lost quad alarm, plug it back in. Okay, twist the wires up so they stay nice and organized. We may end up disconnecting that and reattaching it later. We're not going to directly apply the camera to the little holders. We're actually going to put this little bracket on. It says Fox here on the back. And what we're going to do is those two screws right here are going to go right through there and right through there. And then these three screws are going to be left for the camera mounting. So if I take this little side panel off of here, maybe, there we go. You got to kind of look in this and see what the orientation is going to be. So if we set it up like this, that's not going to work. So we should flip it around, and that's going to work really well. These slots here, 1, 2, 3, should match up like that so we can rotate and tilt the camera in different directions. Next, what we're going to do is we're going to get some M2 size screws. You may need to order a kit. I'll put a link in the video description. So you're going to need both side panels from the frame. We're going to actually mount this to the side panels and then drop it into the frame. You're going to need M2 screws, and the hex head on this particular kit, which I'll link in the video description, is H1.5. Don't go too tight. Just get it started. Okay, so 1/2 is on there. Now, if you loosen them up just a hair, you'll be able to move the camera. So it's like in the frame, you'll be able to like rotate it and lock it to where you want it. So I'm going to pretend like this is in the frame. If I go dead flat, I'm not going to have much of an angle at all, and I'm not going to be able to pitch forward and fly. But if I go like way too extreme up, I'm going to be like facing the sky, and that is not desirable either. So I'm going to kind of go right in the middle. Okay. Now you can do the measurement of degrees on this and decide what angle you actually want. I do not go for extreme angles, so I'm going to kind of go for something like this actually, which is sort of almost flat, but just above. And if we're just starting out, we don't want too extreme of an angle. We're going to put the wire in the back of the camera. We're going to hook this up as well, and this is our OSD function, and what this is going to allow us to do is change settings on the camera. And what I like to do is I'll leave like the joystick attached to it, and then after I'm done setting, I'll unhook just the pad here and then leave the wire tucked up in there so I can get to it later. And we're going to set that in there, and that's it. And there you go. She snaps in. Love this frame for that reason right there. Very awesome camera mounting. That camera is not going to jiggle at all. So we're going to actually set this over there and kind of like right through there. Keep it out of the way. So we got the lost quad alarm kind of shoved behind the camera. And the one thing we kind of want to make sure we have access to is this little button that's on the side of the lost quad alarm so we can turn it off. And it looks like, if you can see here, the button that I'm referring to is right here. Okay? I don't know if you can see that, but basically you'd have to push that to deactivate the lost quad alarm. Again, alternatively, you can just plug a battery in for a few seconds and that'll stop it from chirping. But this thing will do its job, essentially being positioned where it is. If I lose power, if you crash, this thing's going to chirp and let you find it. It's pretty loud, very effective. So, and what I'm going to do is, again, like I said, I'm going to leave that out of the way, but still accessible. One of the things I'll mention about any box style frame like this is go diagonal. Put the front left, go to the very far rear right, and the exact opposite. And now, if the corners are in, everything else will be cake. Just really make sure those are tight. Alright, give it a good once over. Make sure all your screws are tight. Make sure you've got everything mounted the way you like it. Give everything a little push. Make sure stuff doesn't just come flying off. The battery strap I can't recommend enough to you is the Lumineer Unbreakable. They come in various sizes and lengths, but pretty much this, I'll put a link in the video description, of course, as to what size this is. But just go ahead and get this put in there so at least you have an idea that everything is going to fit with the battery strap. And that's where your battery strap's going to go. These things literally are unbreakable. They are super tough. And when you're brand new flying FPV, the cheaper straps are just not going to cut it. You will break them. They do snap. You will crash a lot. It is what it is. So you might as well just get a good set of straps for not that much money that you won't have to be replacing constantly. So we need to mount up the receiver antennas. Okay? So what we're going to do is we're actually going to stick 2 zip ties underneath into the top. And they're going to be both facing the zipped direction, so to speak. So we're going to kind of shove this one in there. Pull it all the way through, and then we're going to do the same thing to this one here. So there's going to be a zip tie that's going to go across right here, and that's what we're going to do next. And then snip. Next, we're going to take and we're going to actually attach the antennas to the zip ties. Go around and cinch it. Bring it up. Right at the base. And we're going to do it again. This time more towards the top. Okay. Just cinch it. Not super duper tight, just so the zip tie doesn't slide around. Okay. So now, when you go to put a battery on this, the battery is going to be kind of sitting here. And you may have to kind of push these out of the way, and that's fine. But this is your XT60 lead, so you got plenty of room if you wanted to put the battery up a little bit further. But this should keep your antenna leads from getting chopped up. We're just about done. So what we're going to do is we're going to do what's called a smoke check, and we're going to plug it in and make sure that this green light stays lit. and that we hear the 3 do-do-do and then the do-do. That tells us that the ESCs are working and the flight controller is working. And that's a great sign. So all 4 motors twitched, so that means that they're all getting a signal. We heard the do-do-do, do-do. That means the ESCs are working. That means the flight controller is working. Everything should be good, and we're not getting the green light dipping out, which means that we are solid. So you hear that beep? That's that lost quad alarm, which is telling us that, oh my god, I just lost power, which we know because I just unplugged the battery. So we're going to go 1, 2, 3, 4, 5. And since this is accessible with a tool, you'll need to make sure you have something that you can always reach that button with, because the button is kind of right there. Again, that's the way I built it. You build it however you want to. Some people, my other TBS Source one, I put it here, but I had a different receiver, so I had room for it. But yeah, so there you go. You're good to go. Now we're going to see if we have video. Ooh. We have to find what channel it's on, so you're going to have to actually go through your quadcopter's goggles and figure out what channel it's on. Ah, looks like we're on A1. Alright, so now you need to use software to configure your quadcopter. You're going to need that little USB port on the side of your flight controller, and you're going to need a micro USB cable plugged into your computer, and one that actually works, which may sound trickier than you think. The other thing you're going to need is to download a program called BL Heli Suite, not BL Heli Suite 32 like you see on the screen there, but BL Heli Suite. Okay, we don't have 32-bit ESCs, so don't worry about that. If you have Windows, download the Windows version. If you have Mac, download the Mac version. You'll also need the program called Betaflight. Betaflight Configurator 10.6. You can go to betaflight.com and or just Google it and find it. And I'll put some links in the description down below. Once you've downloaded and installed Betaflight Configurator and BL Heli Suite, you're going to need to run Betaflight Configurator. So what we're going to do is we're going to plug in the quadcopter, and we're going to open Betaflight Configurator. Now, if this is the first time you've ever done this, it's probably not going to connect just like that. You're going to have to download these drivers and run through the driver installation. STM USB and Zadig is usually the way to go. Sometimes you can run CP210. I usually start with STM, and if that works, you're done. If that doesn't, then go to Zadig, and if that doesn't work, then go to CP210. If that doesn't work, Google it. Joshua Bardwell is a good resource for that kind of stuff, but honestly, it can get a little tricky with Windows. All right, so up here you're going to see a COM number and a baud rate. Basically, if that is not the case, if it says manual selection and you've plugged in the USB, then try a different USB cable if the driver's thing has already been ran through. Try multiple cables before you do anything. So after that, you're going to see COM 5, 6, 7. It doesn't matter. This one says 10, and then a baud rate, usually 115200. Go to connect, and you're going to be met at this screen here. The first thing you need to make sure of is that the quadcopter reacts the way it should based on the nose. So the camera pointing where the arrow is, if you tilt it that direction, it should be doing what you're telling it to do. Okay? So pitch back, pitch forward, roll left, roll right, yaw left, yaw right. Set it back down on a nice flat surface. And again, make sure your propellers are off. If you put them on, take them off right now. Over here, you're going to check enable expert mode. Okay? It's not that scary. Trust me. Just enable expert mode. All right. Once you're on a smooth, hard, flat surface with your quadcopter, you're going to click calibrate accelerometer, and that's going to flatten it right out for you. Okay. We're going to go to the ports tab. Now, I've already done this, so I'm going to give you a quick overview, but remember where we put our receiver? We put it on RX4. Well, in the software, we call that a UART, and we want UART4. UART is like a USB port, but for flight controllers and other devices. So RX, that's the receiver. 4, that's what port we put it on. So we're going to check serial RX on UART4. Okay, remember when we had that smart audio wire for the video transmitter? We put that on TX6. Well, there's UART6, and over here we have peripherals. We click on that, and we go to VTX Smart Audio. And then we hit save and reboot. our ESC motor features first, and there's all these different options. You want to make sure D-Shot 300 or 600 is chosen. I prefer 300 on these ESCs. It tends to work a little bit better in my opinion, but you can go either 300 or 600. Motor idle percentage, you want to set either 5 or 6%. It's really personal preference, but basically this is the percentage where the motors will idle when you're not in full throttle flight. So if the throttle's all the way cut, it's going to sit at 6% when you're just sitting there hanging out. Back to this screen here, if the board is not aligned correctly, you're going to go into this tab and then you're going to mess with these settings. I'm not going to show you how to do that because ours is set up correctly, but if it wasn't, this is where you would want to play with it. If you come down here, we have arming, max arm angle in degrees. 180 basically means that this thing will turn on if the quadcopter's upside down, doesn't matter what angle it's at. You probably want to set it to 25 or 30, and that basically means it can have a slight angle, but if it's not pretty flat, the quadcopter will not turn on. The reason that I set mine to 180 is sometimes you get stuck in places, and just being able to turn on the motors real quick to flip the propellers around can knock you out of trees, can get you out of stuck places. So then you're going to scroll down here, over to here, actually back up, I guess, over to the left, and you're going to see system configuration. You're going to see gyro update frequency, 8%, or 8 kilohertz rather. PID loop frequency, you're going to select 4 kilohertz. And then if these three are checked, just leave accelerometer checked and disable barometer and magnetometer. We probably don't have those anyway. Personalization, you can name it whatever you want. I named mine Source 1 2 because I have another Source 1 frame. FPV camera angle, this is something that'll kind of help you fly. You can also leave it alone if you want, but I do recommend 15 as the minimum. It does help me anyway when I was brand new, and I still set it. So receiver, you're going to need to set this up now. So there's all these different options. You want serial based, and then you're going to want to go to iBus. That's if you're using the FlySky. If you're using something else, then obviously you'll have to go do something else. But if you're using the FlySky, it's going to be serial based and iBus. Okay, other features. Turn every single thing off except for air mode, OSD, anti-gravity, and dynamic filtering. Turn everything else off. You don't need these. Turn them all off. Over here, you can leave these off, and you can leave all of these on. We don't have a traditional beeper setup, so this isn't really going to make any difference to us, but they're pretty self-explanatory. It'll beep when these things occur. Beeps when gyro has been calibrated. Okay, our beeper is set up specifically for if we lose power and we crash, we can go find the quad. We don't really care about all these little beepers to tell us certain things, not at this stage yet. Okay, hit save and reboot once you got all of that set up. It's going to reconnect. All right, we're going to go into failsafe. You're going to want to set stage 2 settings to 6 or 5.5. I like 6, or rather 5, rather not 6. 5 or 6, your choice. Not anything lower, and I wouldn't go anything higher. If you go too low, that's one value equals 0.1 seconds. So 0.4 seconds, not even half a second. That means if the receiver has lost contact with your transmitter after 0.4 seconds, it will just drop you out of the sky. That's not long enough. Sometimes you can regain signal after just over half a second, which if you think about how quick that is, that's really, really fast. 1/1000, half of that to go. Over here, you're going to go to the throttle on channel fallback settings, and you're going to go to set, and then you're going to set it to whatever the min length is here. If it says 885 or 900's fine, you can leave it right there. That basically means that the throttle will go to absolutely nothing, and that will allow the quadcopter to just fall out of the sky. So this is setting up your fail safes in case you lose radio transmission with your quadcopter. Hit save and reboot. All right, we're going to go to PID tuning, and we're not going to touch anything. Leave it alone. Leave all of this alone. Go to receiver. Now you're going to have to plug in your quadcopter. Make sure your props are off. Make sure your props are off. Okay. Then plug in your quadcopter. And then turn on your transmitter, your FlySky transmitter. First thing you're going to want to do is press throttle up. And if you're looking at the screen, then you should be seeing the throttle up and, you know, go up and down, up and down. Then you're going to yaw, which is on the throttle stick, and you're going to yaw to the left, yaw to the right, yaw to the left, yaw to the right. And you see your little 3D animated quadcopter over here should be doing what you're telling it to do. This is pretty much good to go. Now, remember when we set up those switches, switch C and switch D, that's aux 1 and 2. Okay, hit save, go to modes. You're going to need to mimic this, and I'm going to undo all of this to show you how to do it. First thing you're going to need to set up is arm. Hit add range, go to aux. In our case, it's going to be aux 2. So the switch on the furthest upper right is a single position up and down switch. Slide this yellow bar all the way over, hit save, and then if you switch down, that arms the quadcopter. If you switch up, that shuts it off. You can actually set it up however you want, whichever switches you want, but this is the way I do it. This is the way I'm showing you how to do it. Okay, we can set up angle mode. We hit add range. We go to aux 1. This is the 3-position switch. 1, 2, 3. We slide this all the way over, and then when the switch is all the way up, we'll be in what's called angle mode. We can add a link for horizon mode, or I'm sorry, add range. Go to aux 1, and then put it in the middle. Kind of scrunch it down. Hit save, and now if we go to the middle, we will be in horizon mode. And then if we put this 3-position switch all the way down, we'll be in what's called acro mode. So basically it's easy mode, which angle mode is where it will keep you level all the time and will not let you flip or roll. Horizon mode will let you flip and roll, but will automatically correct you. And then acro mode is, well, that's professional flying. You should learn how to fly in acro mode, but for some people that can be a bit overwhelming. So if you set these modes up just like I've done here, angle and horizon mode, you can kind of do easy, medium, and hard mode and kind of work your way up. All right, next thing you need to do is go to the OSD tab. And this is where you're going to set up your OSD. Now, this is the way I have mine set up. You can actually pick these things up, drop them wherever you want on the screen. And then over here are the actual things you're adding to the screen. Personally, I would put your battery average cell voltage, your total battery voltage, to tell you what your per cell is and then what your total is. This gives you an idea. This the 3 volts tell you, okay, if you dip down below 3.5 volts, it's an average. So that's, you know, it's pretty low. It should stop flying when it gets down to about 3.5, and then, you know, it'll rise back up to 3.7, 3.8. This is the total voltage. This will vary depending on what kind of battery you have. If it's a 3S battery, it'll start at like 12.6. And if it's a 4S battery, it'll start at like 16.8. This will tell you the total voltage. If you're really good at math, you don't need the average. So just keep that in mind. The next thing I like to do is craft name, and that's just the name that displays, so source 1, 2, right? Then fly mode is what mode are we in? Are we in stability mode or stab, which is angle mode? If we're in acro trainer mode, or are we just straight up in acro mode? It'll tell you right there on the screen what mode you're actually in. Throttle position is nice because if the throttle's all the way up or all the way down, it'll give you 100 or 0%. If you use this, I use this personally to watch on my DVR to see like what the voltage was in correlation with my throttle. I'm actually not really looking at any of this while I'm flying because I want all my attention to be here in the middle. So I like to leave all this empty and put all this stuff at the very bottom. Throttle position, then timer 2 tells you how long the quadcopter's actually been flying, not how long it's been turned on. So fly minutes means you've been armed and flying for 3 minutes or whatever it is, and that gives you an idea of when you should stop flying based on your batteries. And then warnings is things like, oh, it's battery is critical low, or battery is low, or it's crashed, or there was a fail safe, or whatever. This is something you can watch if you have a DVR and see what was it yelling at you about before it did something, or when you did crash, you can look into your goggles and see, oh, it's ESC fail or something like that. Sometimes that'll pop up. All right, post-flight statistics. You're going to want to set these up too. Otherwise, you're going to be bombarded with information at the end of your flight. Most of it's useless. I turn everything off except for the battery voltage, what it actually is, and that's helpful because I need to see that real quick. Okay, my battery's still good, or nope, I should stop flying. Battery voltage minimum during the flight. So if it's like, oh wow, I got the 3.2 volts, that's not good, I need to stop flying, that'll tell you that. Black box number and black box usage are if you've got that SD card in your flight controller, and this will kind of help you troubleshoot when you get more advanced later on down the road. But this will tell you which file to open and how full your SD card is if you're troubleshooting. So leave those on. All right, motors tab. So we got the icon of the quadcopter. We have 4, 2, 1, and 3. And what you're going to want to do is, again, make sure your props are off. Take your props off. If you have props on, take them off right now. Do it. Okay. You're going to turn on I understand the risk, and the propellers are removed because they better be, or else you're going to destroy everything around you and possibly hurt and kill yourself. So please take your props off. Okay. So we're going to hit that. We're going to make sure we have a battery plugged in. And then what we're going to do is we're going to go over and one motor at a time. We're going to see if, first of all, the motor number here is associated with the one that actually spins in the quad. So click on that, hit page up. And if that motor spins, then you know, okay, motor 1, the back right motor is spinning. That's good. See what direction it's spinning. If it's not spinning the correct direction, which means that it should spin in the way the arrow is. So this is clockwise. And this motor is, in fact, spinning clockwise. So my motor's good to go. I can turn that off. I go to motor 2. That's this one. It should be spinning counterclockwise. So again, I page up 1 or 2 times, and it is not spinning counterclockwise. So I'm going to tell you something right now. All the motors are going to be spinning clockwise because of the way we wired it. So we're going to make sure, though, that 2 is 2, 3 is 3. All right, click on 3, hit page up. Yep, 3 is spinning, and that 4 is 4. All right, so 1, 2, 3, 4. We need to reverse this one and this one because these guys need to be spinning counterclockwise, motors 2 and 3. So we're going to disconnect from Betaflight. We're going to leave the configurator open and leave this information here, and then we're going to open BL Heli Suite. Now, if you have the drivers installed, everything should be hunky-dory here, but if not, you may have to come up to this tab right here and select A, B, C, D, or E. I find that this one works the best, Scilabs, Bootloader, Clean Flight. Sometimes it doesn't. Just, try them all until you get a connection down here. And what you really are looking for is that you see the STM Electronics virtual COM port, and it should match the COM port of Betaflight. Also, the baud rate needs to match as well. That's why we leave Betaflight configurator open. So you hit connect. You hit read setup. Okay, and we know that we got to reverse 2 of the motors. So what you're going to do is you're going to go one motor at a time. So there's motor number 2. Hit read setup. And I've already done it here, but you're going to click reversed and then hit right setup. And then you're going to do the same thing for motor number 3, or whichever motors were not spinning the correct direction. If they say reversed, switch them back over to normal. If they say normal, switch them over to reversed. And then you're going to read all the setups after you've hit right on those changes. Hit read setup. Now this is all 4 together. So from here, we could actually change all the motor directions, which we don't want to do. And we can change all these other options as well. For right now, we're not going to really mess around with these settings. There's nothing really we need to worry about. But if we go into this motors tab, it's actually the same piece of software just about that we were just using in Betaflight. I can click on this, say, yep, the props are removed, and then I can do the same exact test. Make sure the motors are now spinning the correct direction. So motors 2 is spinning counter. Motor 3 is spinning counter. Motors 4 and 1 are spinning clockwise, and that's what we wanted. So we're going to close this, and that's it. You are good to go. So we've got Betaflight all set up, which means we have smart audio all set up. So what we're going to do now is we're going to plug the quadcopter back in. That's a good sign. We've got our little dongle with our camera set up. We've got our transmitter good to go. And what we're going to do is I'm going to turn on my goggles and show you how to do it. So basically right now I've got the camera set up here. I'm going to push and hold the center button. Just tap it there and it says camera ID off. So we're going to leave that off. If you turn that on, it'll just put stuff in the screen from the camera. Hit pick adjust. From here you can actually change your brightness, contrast, sharpness, all that good stuff. This is something you're going to want to do outside, not inside. Day and night, set that to auto, so if it gets a little dark it goes to black and white. Language, whatever language you prefer. Camera reset, resets all the settings. Hit exit. Save all, sure. Hit the up button and hold it. So this is going to show you the options for like the power, the volume alarm, voltage alarm rather, not volume, voltage calibration, what mode you're in. Black and white, LED, day, we'll leave that, and then NTSC or PAL, we're going to keep that in NTSC. And press up on that, there we go. Size 4x3 or 16x9. I prefer 4x3 personally, I think you gain more, but that's just me. On the vertical. Alright, so now we've got the camera ready to rock and roll. Next thing we're going to need to do is we're going to go throttle here and then this stick up like that. That's going to bring up our smart audio. So you have profile, which is your PID profile and all that stuff there. You can change all that here. If you use the throttle stick, you can actually go back. If you go left with the throttle, yaw. Features is our smart audio. So from here we can actually set our VTX channels. So I prefer Fat Shark 1. Looks like we're already there. Hit yes, and then from here I can actually change it over to Fat Shark 1 because it will go out on you. Okay, so the next step is attaching the props and charging up a battery and getting ready to go fly, and that's what we're going to do. The props I've chosen are the Dell prop, D-A-L prop, Cyclone 5040C. So if you're wondering what these numbers mean, 50 or 5 is 5-inch prop. That's what this is a 5-inch build. The 40 is a 4-inch pitch, so it's a lower pitch. It can go all the way up to 50, 51, 52, really high pitch, but for this style build, a 50-40 prop, any brand really, a 50-40 is going to work just great. The reason I recommend Dell prop is because they are incredibly durable. And you're going to want durable props when you're starting out. And not only that, these are just really great flying props. So when you go to install your props, you're going to need 4 prop nuts that came with each of the motor. And you're going to set those aside. You're going to need a 5/16 nut driver or a prop tool if you desire. I like the nut driver because it gives you a better grip. And then you're going to need to set the props on the motors. So these are the motor stems, and you're going to look at the props and you're going to make sure that the labeling is on the top side. That's right side up. Okay? And the props go in 2 different directions. They're going to be curved downward facing this way, and then curve the opposite direction facing the other way. Pretty much what you're going to do is you're going to pretend like this is the front, the mouth, and this is the butt, the rear. You need to make sure that the props are able to spin inward toward the mouth, giving it air, and then inward towards the butt, cooling it off, if that's, whatever works for you. So you set the props on the stems like this. So these two will be opposite of each other. So they're going to be with the fins going this way. It's going to be facing inward, and when they spin, they're going to be spinning towards each other. Okay, the exact same thing back here. You're going to set this one, and these two will actually match. That's a really quick, easy way to figure out which way they go. These two and these two will be the same. And so this is going to be spinning inward toward the rear, and this is going to be spinning inward towards the front, the nose, the mouth. Okay, so once you have your props set up, so these are tilted this way, these are tilted the opposite, these two are the same, and these two are the same, you're going to set your prop nuts. And just basically get them on there hand tight first, and then we're going to wrench them down. So once you get them there, grab the motor, turn, and that's it. The same thing. That's it. I like to just kind of hold the motor and just kind of push on the prop, make sure that they can't just spin freely. With brand new motors and props and prop nuts, that should not be the problem. All right, let's go charge up some batteries. Okay, we're at my charging station. Forgive the echo. It's in a basement surrounded by concrete walls, but, you know, bear with me. So if you went the 3S route and you ended up getting the IMAX RC charger, you're going to plug in the balance lead of the battery pack straight into the charger. After you plug it in, you're going to have 3 red lights. When they all 3 go green, you're ready to fly. It's that simple. If you got the IMAX goggles, you're going to plug it into a micro USB connector. It's going to be green when it's charging and red when it's done. It's kind of counterintuitive, I think, but that's how it is. It's an 18650 battery in there. If you want to, and you're going to end up with more 18650s if you stay in this hobby, get an 18650 charger, which charges off of a micro USB, and it can charge 2 of those at the same time. So links in the video description, of course. And then the goggles plug into their charger. It's red when it's charging and green when it's done, the opposite of the Emax. So if you went with the Eachine goggles, that's how those are going to work. And if you decided to go all in and get the ISDT setup, that's what we're going to show you right now. Okay, so you are going to need to pick up balance leads for charging. It's got female and male on each end. It's pre-made. I'll put a link in the description where you can get these. But pretty much, you're going to plug the lead into the charger unit and then the XT60 into the charger unit. What we're going to do is we're going to see, this is where this battery pack is at. This is the 4S pack. We're going to click on that, this button here, and you're going to see each cell voltage. If it says 3.8, that means it's at storage, which is where you want to leave your batteries, 3.8 per cell. So we're going to click on that again. We're going to click this scroll wheel, and basically you're going to set it to charge. So charge, discharge, storage, we're going to choose charge. And then your voltage or your battery type should be LiPo, not any of these other ones unless you have one of those other ones. And then your cell voltage should actually be at the thumbs up. 4.2. That's the maximum they should ever go. You scroll down here, it says cell count 4. Pretty much don't change that unless something is incorrect. If you have a 3S pack and it says 4S, take a look at something, but make sure that it's the right amount for the cells you have. You have a 4S battery, it should say 4S. You scroll down here, current setting. So you have all these different options. Depending on what type of battery pack you have will determine this. So if I look at this battery, it says 1300 milliamp hour. So basically we move the decimal point over 2 places, and instead of 1300 we get 1.3. And that's how you determine how to set this at. We call that charging at 1C. You do not want to go above 1C. You can, it's probably okay, but you'll basically wreck your batteries quicker. There's no real reason for it. Charging at 1C or whatever the milliamp hour is, moving the decimal over 2 places, that will make sure your batteries last a good long time. So we're going to say 1300 milliamp hour or 1.3 amps. We're going to scroll down, hit start, and now it's going to start charging. The reason I like this charger so much is because it's pretty idiot proof. If I did something wrong or if something got unplugged, it's going to yell at me and go, hey, something's wrong. And that's it. It's going to stop charging. It's going to keep making that noise, by the way, until you do something about it. So don't be too far away from it when you're charging your packs. But that's pretty much getting your battery set up on the ISDT D2. It's probably not a terrible idea to get a strap for your radio. Again, your radio is going to look a little different than mine because I've modified it, but buy a strap for it, and it is a lot easier to put around your neck and carry. So if you have it set up the way I did in the video earlier, you're going to want to make sure that switch D is channel 6 and switch C is channel 5, and then aux 1, aux 2 in beta flight, just like before. This should arm the quad. And as you can see, the props are spinning. This will change your modes, and then this will disarm the quad. The thing you do before you ever take off is verify your failsafe works. And what we're going to do for that is we're going to turn on the quadcopter. We're going to throttle up just a little bit. It's not flying. We're going to turn off the transmitter. It should do that. That means the failsafe system worked. And now we're back to 0. Now we're going to do a hover test. This is where skill comes in. Alright, so we throttle up just a little bit. Make sure you're away from all people, objects, yourself. Just be safe about this. pitch forward, pitch back, roll left, roll right. Make sure you got all directions, and you're going to want to make sure that you're starting in angle mode, which if you set up the way I showed you in Betaflight is a switch all the way up. So here we go again. And just practice getting good at taking off, moving around, and flying. Once you get good at doing that, you can move on to doing some acro and really just kind of progress. But that's it. You're all set. Hopefully this was a good video for you. Please let me know what you think down in the description, down in the comment section. Thank you.